Who hasn't heard or sung these words? While this poem is only 200 years old, but stars and skies have made humanity wonder since time immemorial. It's not surprising that for scientific community too, stars and skies offer an unusual laboratory. Indian scientist S.Chandrasekhar also got captivated with the mysteries of stars. And that ultimately made him become a permanent star on the horizons of astrophysics. Modern science has witnessed many outstanding scientists who revolutionized the human understanding of nature. Chandrasekhar surely is one of the foremost among them. With his prolific contributions to wide-ranging fields in physics, astrophysics and applied mathematics, he became a legendary figure. He has undoubtedly left behind a rich legacy of scientific accomplishments. Chandra lived on Earth and worked in space.
So what is this whole business? After all, what is happening in the core of the sun, what is happening is 4 hydrogen atoms fuse because of nuclear fusion to 1 helium nucleus. And the mass of the helium nucleus is less than 4 times mass of the hydrogen nucleus, and therefore because of the conservation of energy, mass energy, there will be energy liberated. according to Pauli exclusion principle,
Gas is degenerate when all the particles within the gas are packed densely and the self-gravity is counteracted by pressure arising from Pauli's exclusion principle. Pauli's exclusion principle says that no two identical spin half particles can have exactly same quantum states. This basically means that no two identical spin half particles can be at the same place at the same time with spin pointing in the same direction. Pauli's exclusion principle does not favor increase in density. In white dwarfs, electrons become degenerate, while in neutron stars, neutrons are degenerate. A star with initial mass less than 8 solar mass becomes a carbon-oxygen white dwarf with gravity counteracted by electron degeneracy pressure. A star with an initial mass greater than 8 solar mass evolves into an iron-rich core, after which nuclear fusion shuts down. Now the core contracts and the iron nuclei are crushed further and they turn into neutron-rich matter. If the degenerate neutron-rich core is less than 2 to 3 solar masses, the core becomes a neutron star. This is a kind of Chandrasekhar limit for neutron stars.
that for white dwarf, the degeneracy pressure is proportional to the density to the power 5/3. Chandrasekhar was the first person to realize that in the iron core inside the white dwarf, most of the electrons are actually moving with speed close to the speed of light. Of course, nothing can move faster than the speed of light, but what Chandrasekhar realized are these electrons are moving with speeds close to the speed of light. But once you have electrons moving with speed close to the speed of light, then new effects come in, that means relativistic effects come in, and that makes them grow not as density to the power 5/3 but density to the power 4/3.
In fact, the Pauli's exclusion principle of quantum mechanics restricts the number of electrons that can occupy any energy level. This, along with relativity, lead to Chandrasekhar limit. Einstein's theory of relativity predicts many strange effects. One is that when an object's speed changes, so does its mass. For example, if it were possible to weigh a person traveling at 90% speed of the light relative to a stationary person, he or she would weigh far more than normal. But to them in their rest frame, however, everything would seem normal. It is this feature that leads to the famous E is equal to mc square formula. His life journey was full of accolades. Beginning with the Fellow of the Royal Society in 1944, he was honored with Henry Norris Russell Lectureship in 1949, Bruce Medal in 1952, Gold Medal of the Royal Astronomical Society was given to him in 1953, and then came the National Medal of Science, USA in 1966. And in 1968, he was honored with the Padma Vibhushan, and that followed by Henry Draper Medal in 1971. The big one, the Nobel Prize in Physics, came in 1983. He was also accorded with Copley Medal of the Royal Society in 1984, Honorary Fellow of the International Academy of Science in 1988. In 1995, Chandrasekhar's death brought an end to an unforgettable era, and that's the reason he continues to inspire the scientific minds even today. And what a tribute to this! His ashes were sprinkled all over the Chicago University campus.